let's talk about some tips and tricks for two-dimensional figures. Number one, which statement about the following figures appears to be true? So which one is correct? Okay, so let's see what it's talking about. It says figure X and Y have one pair of parallel sides. So X and Y. So here's X, right? And they're talking about parallel sides. But what I noticed about X is it's a triangle. So it's a three-sided figures. And for it to have parallel sides, you have to have at least four sides, right? So you can see if opposite sides are parallel. So if it's talking about parallel sides, I know X isn't going to have any parallel sides again because it's only three sides. And take a look at Y. Well, this one is parallel to this one. So where Y does have one pair of parallel sides, but take a look at this one. This one is not parallel to this one. They're not at the exact same tilted direction. Those would intersect. So figures X and Y have one pair of parallel sides. Well, that's true for Y, but that's not true for X. So that one's not correct. Figure X and Y have at least one pair of perpendicular sides. Remember, perpendicular, perfect cross. So let's see. And I also know that big L-A-R, perpendicular lines have right angles, right? So let's see. X, take a look. This one and this one, when they come together, what do they make? A right angle. So that one does have one pair of parallel sides because it'd be this side and this side. Now let's take a look at Y. This one and this one make a square corner. So this side and this side are perpendicular. And then this side and this side makes a right angle. So it's perpendicular. So does X and Y have at least one pair of perpendicular sides? Absolutely. Figure Y and Z have all obtuse angles. Let's take a look at Y. Well, this one's already acute. This one is obtuse. This one's right, and this one's right. So all obtuse angles, that's not true. Figures W and Y are congruent. Congruent, same size, same shape. Congruent, same size, same shape. So is W and Y the exact same size and shape? Absolutely not. So our answer is B, because they did have those right angles, which makes perpendicular sides. Darlene sketched 4 figures below on a dry erase board. What is the total number of obtuse angles for the figure she drew? Well, we have no choice but to label all of our angles and then count the obtuse. Well, this is a rectangle, and what I know about rectangle is they're all square corners. So a rectangle has nothing but right sides. Okay, take a look at this rhombus. See how wide that one is? That's an obtuse with a big caboose, which means the opposite side would be obtuse. Take a look at this one. This one, see how this one's mostly closed? So this one's acute, which means this one will be acute. Okay, let's take a look at trapezoid. The trapezoid, the distant cousin of the quadrilateral family. Okay, take a look at this one. This one's acute, mostly closed. This one's acute, mostly closed. Take a look at these top ones. Look how wide that is. So this one's obtuse, and this one's obtuse. This one looks like a square. I can make a square out of that corner. I can make a square out of this corner. Take a look at this one. This one's acute, it's mostly closed. And this one's like going angled up, so it's an obtuse. So how many total? I have 1, 2, 3, 4, and 5. 5 obtuse angles. So our answer is G on our test-taking skills. Okay, number 3 on our test-taking skills. These polygons belong in the same group. Which statement best describes the polygons in this group? Each polygon has at least one pair of parallel sides. Let's take a look. I know that this one is parallel to this one, but this one is not because this one's tilted down, so it eventually run into this bottom one. But it does have one pair of parallel sides. Take a look at this next one. This one, no parallel sides. So each polygon does not have one pair of parallel sides. Each polygon is a quadrilateral. Here's how I remember quadrilateral. Uno, dos, tres, quadrilateral. uno, dos, tres, quadrilateral. So quadrilateral has 4 sides. Let's see. 1, 2, 3, 4. Yep. 1, 2, 3, 4. Yep. And 1, 2, 3, 4. And I'm sorry about this right here. It is printed wrong. But it does have 4 sides. So that one's a possibility. Each polygon is a trapezoid. I think this one's a special type of trapezoid, but these two are definitely not trapezoids. So that's not true. Each polygon has at least 2 acute angles. Let's see. This one's a right and this one's a right because those are square corners. This one's angled down, so this one would be an acute, and that one's angled up, so that one would be obtuse. So each polygon has at least 2 acute. Well, that's already not true just based on this one shape. So our answer is B. Now take a look at 4. I'm really glad they put a symmetry question on here because you've been practicing that for the last few days. Which figure appears to have exactly 1 line of symmetry? So I know that a line of symmetry can either be a vertical line, horizontal line, diagonal, or the other diagonal. So that's just my tester, VHDD. So taking a look at this one, can I go vertically? So if I fold my paper like this, would it fold on each other? No. So it's not going to be vertical. How about horizontal? If I fold it like this, would it fold on top of each other? No. If I went vertically, now at first, this appears to be, like if I go like this, it would, but that's not true because look how much wider this one is and this one's thinner. So that one's not true. And the other diagonal would be this direction, right? Well, that one just doesn't work either. So F actually has no lines of symmetry. Okay, so take a look at G. Vertical, horizontal, diagonal, and diagonal. That's how I'm going to test it. So if I go vertical, could I fold it like this? Let's see. Absolutely, it'd fold exactly on each other. So yes, so vertical would work. Horizontal, if I would go like this, no, because that side would be like a square and then that would be like an arrow. So no. Diagonal, if I fold it that way, no. And what if I fold it? What if I went the other diagonal and I went that way? Nope, that would not fold on each other. So that one does have 1. So that one's a possibility. Vertical, horizontal, diagonal, and diagonal. Well, if I went vertical, was straight up and down, this one would come longer than this point, right? So those would not fold on each other. Horizontal will be this direction. Well, this side has just like these square corners, and these have like these like come to points here. So no. Diagonal, if I was to fold it like this, nope. What if I went this way? Would I? Nope. So that one has, again, no lines of symmetry. Now take a look at J. Vertical, horizontal, diagonal, and diagonal. So if I go vertical, could I fold these on top of each other? Absolutely. If I went horizontal, would these two fold on top of each other? Absolutely. If I went diagonal, would those? No. And what if I went the other diagonal? No. So this one has 2, but it only looked for the one that had 1 line of symmetry. So J has 2. That one's not true. So our answer is G. All right, there's your tips and tricks. Make sure you are doing your best and enter your scores on the form. We got this.